It's me, Mom Lyra, your math sweetheart, and I am here to help you develop your mathematical skills. So, how are you, grade 10 students? I hope you're all feeling great and okay. Well then, so let's begin a fun and exciting math lesson for today. But before that, please take note of the following reminders. First, have your self-learning module, pen, and paper ready. Then, you may also play or pause this video whenever necessary. And you can even go back or revisit some parts of this video lesson. So, are we all set? Are you ready? Then let's get started as Sir Rusty discusses the lesson. Take it away, Sir Rusty.
Thank you, Ma'am Lyra. In this video lesson, we will have a deep understanding of what permutation is and the most essential learning competencies for Quarter 3, Weeks 1 and 2 are the following. First, illustrates permutation of objects. Then, solves problems involving permutation. After completing this module, you should be able to define and illustrate factorial notation, illustrate permutation using systematic listing method, tree diagram, and the fundamental counting principle. Now let's talk about permutation. Permutation is one of the counting techniques in probability to find the number of outcomes in an event. By definition, permutation is an arrangement of objects where order is important. Again, order matters. Examples of permutation that we use in our daily lives are our ATM PIN code, our cell phone numbers, our social media account passwords, and a lot more. Included in this lesson are the 3 different ways to illustrate permutations of objects. First is the systematic listing method, then the tree diagram, and the factorial notation for the fundamental counting principle. Let's now activate your math skills by answering the preliminary activity. Activity 1 is entitled Arrange Me. All you have to do is to list all possible 3-digit numbers with digits 1, 2, and 3. You may pause this video while answering the activity and just hit the play button when you're ready. Take your time. Do you think you got the correct answers? Let's find out, shall we? The first method in illustrating permutation is systematic listing. By the name per se, it is just listing all the possible arrangements or outcomes in a systematic and organized way. To answer the activity, we could start by listing the possible arrangements starting with 1, then 2, and 3. The numbers that start with 1 are 123 and 132. For 2, we have 213 and 231. For numbers beginning with 3, we have 312 and 321. And that gives us 6 3-digit numbers. Take note, however, that this method is most applicable when you have fewer objects. When you start finding permutations of greater number of objects, it would definitely consume your time. The next method is the use of a tree diagram. It is a simple way of representing a sequence of events. A tree diagram starts with one item that branches out into 2 or more, which branches out into 2 or more items, each of which branches out to another 2 or more items, and so on. Now, to find all the possible 3-digit numbers in our activity number 1, we could illustrate the possible permutation like this. 1 branches out to 2, which then branches out to the remaining items. That gives us 123 and 132. Then, we can do the same for the rest of the items and we'll get the same answer, which is 6 3-digit numbers. Lastly, we can illustrate permutations by using the fundamental counting principle. It is a rule used to count the total number of possible outcomes in an event. By definition, it states that if there are A ways to do one thing, B ways to do another, and C ways to do another, then there are exactly A times B times C ways of doing those things. In the given activity, we can illustrate the number of possible permutations by starting with place values. For example, if we use boxes to represent place values, then take the first box as a hundreds place, the second box be the tens place, and the third box be the ones place, and start filling in the hundreds place, we have how many choices? Any idea? That's correct, we have 3 choices. Those are number 1, number 2, and number 3. If you take one of them to be in the hundreds place, say 1, there are now 2 numbers left for the tens place, which are 2 and 3. If we take 2, then we'll have 1 number left for the ones place. And by using the fundamental counting principle, the number of possible 3-digit numbers is 3 times 2 times 1, which is equal to 6. Let's have another example. David invited his friends Louis, Melvin, Lyra, and Lorna on his son's 7th birthday. He prepared a special table with chairs placed in a row to be occupied by his 4 friends. In how many ways can they be seated in a row? Again, to illustrate, David prepared 4 chairs for his friends, Louis, Melvin, Lyra, and Lorna. We are asked to find how many ways can his 4 friends be seated in a row. To solve this using the fundamental counting principle, let us count the number of persons who can be seated in the first chair. How many of them can choose to sit in the first chair? That's correct. The 4 of them can take the first chair. Let us say that Louis seated on the first chair. How many people could still choose to sit on the second chair? You are right, 3 of them can be seated on the second chair. Suppose that Melvin took the second chair, how many of them can sit on the third chair? You are right again, only 2 of them can choose the third chair. That's Lyra and Lorna. Then if Lyra will sit on the third chair, there will only be 1 person left to be seated on the fourth chair, that is Lorna. To solve the number of ways they can be seated in a row, we can apply the fundamental counting principle and multiply 4 times 3 times 2 times 1, which is equal to 24 ways. Or we could just simply use the factorial notation, which is denoted by an exclamation point, where exclamation point is read as factorial and n represents the number of objects. To simply put, n factorial is the product of a number n down to 1. In the problem, the number of objects is 4. If we use the factorial notation, we will have 4 factorial, which is equal to 4 times 3 times 2 times 1, which is 24 ways. Let's have more examples. This time, you need to get your pen and paper and solve for 3 factorial and 6 factorial. Are you ready to check your answers? 3 factorial is equal to 6. 6 factorial is equal to 720. Were you able to get the correct answers? Great job! Take note of the special cases in factorial notation. 0 factorial and 1 factorial are always equal to 1. And now, you have a deeper understanding of what permutation is. And when we talk about permutation, order matters. You were also able to learn the different ways to illustrate permutations, which are the systematic listing method, the tree diagram, and the fundamental counting principle for factorial notation. Alright, grade 10, now's the time for you to answer the remaining activities in your self-learning module. Good luck!
Awesome! I hope you've learned a lot. Never give up, and remember, winners never quit and quitters never win. Keep loving math! And that concludes our video lesson for today. See you again in our next math video! And this has been your math sweetheart, Mom Lyra, saying, learning math will always be fun and easy. Take care! Love that!